The last set of equations that we're going to learn are the stepping equations. Now for this particular equation we're going to use Kathy. Kathy's our case study, and she weighs 110 pounds. She wants to step at 20 steps per minute. This is also known as the step rate, the steps per minute. And she wants to use a 4-inch bench. Now I want to point something out about this step rate. Step rate is stepping up with both legs and stepping down with both legs. That is considered one step. So for example, if I step up with the right, step up with the left, step down with the right, and step down with the left, that is considered one step. A lot of times when you're taking a step class or where you're stepping to music, you're stepping to what's called beats per minute. This is different than the step rate. If you want to get step rate from beats per minute, you take total beats per minute and you divide by 4. But just to make matters simple in this class, I will give you step rate in this format right here, so you won't have to do any conversions. So we want to know from this example her VO2, her METs, and then her calories that she burned, calories per minute. Step 1, convert the raw data. So I'm going to need to convert her weight from pounds to kilograms. Again, you just divide by 2.2, and that's going to give us 50 kilograms. And I also need to convert her step height. Her step height, she's using a 4-inch bench. So in these equations, it's asking for step height in meters. In order to convert inches to meters, our conversion unit is 0.0254. So I'm going to take inches and I'm going to multiply times 0.0254, and that's going to give me 0.10 meters. So these are our basic conversions. Next, we're going to go ahead and solve. Step 2. Solve the equation. So let me go ahead and write the equation out. 3.5 plus 0.2 times step rate plus 2.4 times step rate times step height. The step rate was 20, that was a given. And then the step height, we did the conversion, was 0.10. When you do that math, you're going to get 12.3 milliliters per kilogram per minute. This is in gross terms. Okay, again, all of these equations give VO2 in gross terms. Step 3. We're going to convert our answer into the desired units. And we already have VO2 because we just figured that out, so we don't have to do a conversion there. But we do have to convert our MET. So we have 12.3 milliliters per kilogram per minute. We're going to divide by 3.5 because that's our resting component, and that's going to give us 3.5 METs. And then our last step is to figure out kilocalories. We're going to take 12.3 multiply times 50 divide by 1,000, and we're going to take, of course, that's going to give us liters per minute, but I'm going to go ahead and put these two steps together right now. In order to get calories, we take our answer there, we multiply times 5, and that's going to give us 3.08 kilocalories per minute. And again, if we wanted to know how many calories she burned for an entire workout, we would take her calories per minute and we would multiply times the total minutes. So if she was going to work out for an hour, we would take 3.08, multiply that times 60, and that would give us total calories burned.